Now that we've found the force of friction, we can use this information in order to solve part B. Part B states from part A, find the speed of the car 10 meters after the brakes are applied. Okay? What I'm going to do here, first of all, they want the speed. So what that tells me right there is I'm going to use kinetic energy somehow, some way, because it has a velocity term in it. So somehow we need to involve kinetic energy. Now, what I start thinking of immediately is the work energy theorems, because the work done by non-conservative forces is delta KE. And again, if you remember, delta E is the change of potential energy, gravitational potential energy, plus the change in kinetic energy. And this is for this system. Delta E changes for every type of system that you're talking about. You could have heat, you could even have other forces acting on it and other changes of energy involved in the system. But in this case, we're only interested in the change of potential energy as well as the change in kinetic energy. And this right here allows me to solve for the speed variable that we're after. So let's start plugging in our values. So the work done by our non-conservative forces will begin by labeling what the conservative forces are and what my non-conservative forces are. We know that my conservative force is gravity, and we know my two non-conservative forces are the normal force and the work done by friction. Now we know that the normal force does no work, but friction does do some work. So what we could do here is use this value, the values for friction, and solve for the speed. And here's what this looks like. So the work done by non-conservative forces is equal to delta E, and this is equal to the work done by friction in this case, which is equal to the change in potential energy plus the change in kinetic energy. But potential energy can be canceled out here to 0 because the height, because this is just going forward, the height is 0. So your initial potential energy will have a value of 0 joules, and your final potential energy will also have a value of 0 joules. Did those values change? Is there a differential? No. Therefore, there is no change in potential energy. But there is a change in kinetic energy because we start off with 12 and we're going to end up with some different speed value here. So if we continue writing this out, the work done by friction is equal to 1/2 mv final squared minus our 1/2 mv initial squared. Now the difference between this situation and part A, when we came to this point, is we were able to cancel this out because it was stated that the car comes to a complete stop. But in this situation for part B, it's not at a stop yet. We're taking that moment when the car is still braking and slowing down. It hasn't come to a full stop yet. And that's the difference between this part and the numbers we were dealing with back in part A. So again, if we continue on with this equation, we get 1/2 times 1500. We don't know the final velocity yet. Minus 1/2 times 1500. We do know our initial velocity, which is given there, which is 12 squared. So let's clean this up. The work of friction is equal to (750) times our final velocity squared minus, this value is minus 108,000. And now you can actually solve for the velocity term here, because we already know the work done by friction, which is given right here. We know the work done by friction because if we go back here, we know that the force of friction is 2160 newtons, and we can use that value and calculate the work done by friction using our work equation right here. Now we know these values. We know this is 2160 newtons, and we know the displacement. In this case, it is not 50 meters. It's 10 meters. Okay? Keep that in mind. This is 10 meters. And the angle, recall that the angle will be 180 degrees because friction opposes the displacement. And to go over it one more time, here is the situation. We have the car and it's moving forward, and the force of friction is acting towards the left in this situation. So focus your attention in this circle. The force of friction is moving to the left. This is my force of friction. And in black, I'm going to draw my displacement. Okay. The displacement is 10. The force of friction is acting to the left. The angle it forms is 180 degrees. So it's the cosine of 180. And if we continue to solve this, we know the force of friction is equal to negative 21,600 joules. Now let's use that value and solve the rest of this equation. So we have negative 21,600 joules is equal to 750 times our velocity squared minus 108,000. And using our calculator, let's plug this value in. So we have 21,000 plus 108. Then we divide that by 750. And don't forget to take the square root of it. And in this case, I am getting an answer of 10.733 meters per second. And that is how you solve part B, again using the work equation combined with the work energy theorem. And for many questions like this, you can use the same techniques. You can use the same techniques to solve almost any type of work energy question. Hopefully that helps. Thank you. Thank you for watching.